Okay, so today I'm going to be talking about customer churn in the banking sector. Um, First, a little bit about myself. My name is Prahlad Wolf. There's some details there, but I'm an organic and sustainable agriculturist and an aspiring data science and problem engineer. Quite a polarity in jobs, but I'm into it. So for the content for today's presentation, I'll be going through an introduction, the data, an analysis of the data, and we'll be creating a model to fix the problem. And we'll go through the conclusion of the data modeling and go through some questions. So first, introduction to customer churn in the banking sector. Most of us might know what customer churn is, but what customer churn is referring to is the phenomena where a customer discontinues their relationship with a bank, either by closing their account or ceasing to use the service. It is widespread and it costs a lot of money. The cost of customer acquisition is 5 to 25 times more expensive than keeping a pre-existing customer. So you want to retain the customers that you have to increase the bottom line. Profits by increasing the customer retention rate by just 5% could be 25 to 95% increase. So it is very important for customer retention. So for the problem, we'll identify trends and patterns in the data. We'll train a machine learning model that identifies customers that might be potential to churn, and we'll develop specific data-backed retention strategies to mitigate customer churn. And then we'll implement, the end goal is to implement the strategies to improve customer retention. So looking at the stakeholders of who might be interested in having this model around, bank executives. Bank executives would seek solutions that not only reduce customer churn, but lead to sustainable and renewable long-term success. Marketing teams would aim to attract and retain customers by implementing the strategies that would be created. And customer service teams would aim to improve the customer experience by implementing the preventative measures to reduce complaints. So the goals and objectives is to specifically build a model to detect at-risk bank customers for the specific data, and in general identify areas for improvement to minimize customer churn. Looking at the data is a data set from Kaggle called Banking Customer Churn. It has 10,000 unique records, and it does have some outliers, but those were kept in the data set as this is real world demographic data, so there's no need to remove the outliers. The data set contains demographic, financial, and customer satisfaction information. Some of the key features would be geography, gender, age, how long they've been at the bank, their balance, credit card, ownership, customer activity, and satisfaction score. So, sort of standard data that will be kept by banks. So, analyzing the data to identify patterns and trends. Firstly, looking at the main target variable that we used for the machine learning is the customer churn. 20% of customers left the bank while 80% retained. It's about 2,040 to 7,960 out of the 10,000. Looking at the customer age was one thing that I did. The age of the overall customer is about 38%, and the average age for a customer who exited the bank is 45. This shows that there is a disproportionate size of older customers who are leaving the bank, as you can see from this graph here. It shows that most of the customers that are leaving are older, while most of the customers in the bank are younger. This is also shown by the customer age against the churn status if they exited the bank. Most customers are within the 30 to 40 year olds, while the customers who churn the most are from 50 to 60. as you can see here, 50 to 60, 56% of customers are churning, while the main demographic only 12%. Customer gender. Female customers were churning at a higher rate of 25% against male customers who were churning at a lower rate of 16%. The amount of female to male customers are comparable, so this is showing that there needs to be more thought put into female customer attention. Another thing is that customer satisfaction, when surveyed, the satisfaction score average was 3, which was the same for customers who stayed and customers who exited. This will be important with the next metric, is customer complaints. Now, customer complaints have a 1-to-1 ratio to the customers who churn. So if you have a complaint, you basically are leaving the bank guaranteed. And this is interesting as customer satisfaction is average, while customer complaints is 1-to-1 to exiting, which shows that there needs to be a thought put into customer complaints. As I said before, there's a correlation between the complaint feature and the target variable that is 1-to-1, and that will need to be looked at. And also looking at the relationship between the target variable and most of the other variables, there isn't much there, which shows that the relationship is nonlinear and will show up later in feature importance. So talking about feature importance, preliminary training was done using multiple models, and the complaint feature came up as basically a 1-to-1, which also made all the other features basically useless. And the models that were being trained were getting 100% accuracy, which is overfitting. So the complaint feature needs to be removed for accurate model prediction. Talking about model prediction, data preparation. So to prepare the data for model training, redundant features were dropped, including the complaint feature, which was important. A standard scaler was used to normalize the data, and SMERT was used to deal with the class imbalance. There was a very heavy class imbalance due to it being an 80-20 split of the data, so that was used to mitigate that. So the data was split into test, train, and validation sets, and a whole bunch of models were just thrown at the wall. The base models of logistical regression, random forest, SVM, naive Bayes, decision tree, k-neighbors, XGBoost, and gradient boost all tried, and out of those, SVM, XGBoost, and gradient boosting were chosen to continue looking for a model that can be used. They were chosen due to the high accuracy score. So going into hyperparameter tuning to fine-tune the 3 models that might be used. Grid search was used to find the optimal parameters for each of the models, with the scoring used as recall. Recall is a very important metric, especially with this problem, because having a low false negative rate would be crucial to keeping up the business, as ensuring that the customer who is likely to churn won't be mistaken for a customer who is not going to churn. So recall was important. Cross-validation was also used to ensure that the models were consistent and not overfitting. As you can see in these 3 graphs, gradient boosting was obviously the best choice, recall accuracy and cross-validation accuracy. So gradient boosting was chosen. The validation set was also used to prevent overfitting. The validation data or the validation metrics was better than the training data, which is unusual, and so there probably was a problem with the model training, and that will need to be looked at later. But it is good that the validation data was not less than the training data, which says that the model is not overfitting. So yeah, the final model chosen was gradient boosting. It had a high accuracy score, it had the best recall score, and it had a good cross-validation accuracy. Looking at the feature importance, this is a lot different from previous one. The feature importance without the complaint feature shows us a couple of metrics that might need to be looked at that wasn't looked at previously, due to the correlation matrix being the base of some of the exploratory data analysis. So here we can see that age is an important feature, which was explored. Is active member, so is the customer active within the bank? It's also important. Number of products is important, and gender female, which was explored before, is important. So these three are sort of the main important ones, or these four are sort of the main important ones, and in future could be used to understand customer churn rates better. Looking at the metrics of the gradient boosting, we can see that in the confusion matrix, there's a very low false negative amount, which is what we want. The area under the curve is 0.96, which is high, which is showing that the model is accurate, and the precision recall curve is also quite good. So yeah, I think the model achieved the final accuracy of about 86%, which is good within the industry standard and will be a valuable addition to the banks. So in conclusion, what the data tells us and what can be done. So firstly, retention strategies should be used to retain predictive leading customers. Using the model, we should be able to predict when customers are going to churn, and we should be able to use preventative measures such as sending special deals or giving the customer a call or reminding the customer of the bank's services and how good they are compared to other banks. These strategies will improve customer retention when we've detected that they're about to churn. Looking at more of a general standpoint from the data, older customers have a high churn rate while being underrepresented, I can't say that word, underrepresented in the population distribution. So providing tailored financial solutions to them will reduce this, such as retirement planning or other investment opportunities that will improve the high rate of churn in the older demographic. Also looking at female customers, the higher rate of females exiting the bank should be investigated, and marketing and customer service strategies specific for them should be created. This will improve customer churn in that demographic and will improve customer churn in general. Customer complaints. There's a one-to-one relationship between customers who complain and customers who exit in conjunction with average satisfaction. This is showing that the customer complaints pipeline needs to be either changed or improved. This can be done by addressing customer complaints quicker, providing more satisfactory solutions, or bolstering the customer support channels to make sure that the customers who complain aren't, guaranteed to leave. And the average satisfaction metric between the customers who stay and the customers who are churned or customers who exit shows that the way that they're gathering this customer satisfaction might be inadequate to reach the people that they need to reach, the customers who are complaining and who are at risk of leaving. So from that, talking about future improvements, The improvement number one is that the data is a snapshot and could be improved with time-sensitive data for each customer. Also looking at more complex data and a more complex model to understand the nuanced relationship between the features that can be discovered. As they're non-linear, there will be more of a complex relationship. Yeah, being trained on a larger data set would be nice. And the final improvement is a continuously updated data set, and regular re-evaluation will prevent the model from degrading in accuracy from the changing in customer behaviors. In 1 or 2 years, maybe customers don't buy credit cards anymore or something like that. And so being able to reevaluate and understand customer behavior through implementing new iterations of the model would be the way to go. Yeah, thank you for being in my presentation. Is there any questions?